Hi everyone, and welcome to our video on the introduction of vectors. So vectors are a quantity determined by a magnitude and a direction, such as velocity, acceleration, force. So for instance, like here's a velocity, 20 meters per second east. So we want to know how fast it's going and where it's going. Okay, whereas a scalar, so going kind of backwards, is just a quantity by magnitude only, such as like mass, volume, distance, temperature. Okay, so like 15 grams, 32 degrees. Okay, so we know just by that one number in units, we know exactly what's going on. Whereas these, again, we would like to know where it's going. Like, where is the force being applied? Is it being applied left, right, up, down? What's going on? Okay, anyway, so that's what vectors do. Visually, vectors are represented using this short kind of ray segment where it has initial points at A and terminal points at B. Often we denote them as a letter that's very bolded out. So for instance, like we might say, this is our vector V. Now I'm bolding it as much as I can. Usually, though, since we're writing things down with pencil and pen, the other way that we denote it is V with a little kind of arrow above it. Okay, so that's the way that we can denote it with our pen instead of going wild with bolding. I guess if you have like Sharpies nearby, you could do it every time. Okay, but I would just do the little arrow. Okay, the other way that we could say this vector is also start with A and it goes to B and show the same arrow. So starting at A, going to B. So all of those are the same designation. All right, the length of a vector is called the magnitude or norm, and it's denoted using the absolute value symbol or like a double absolute value symbol. Okay, so it just depends on the notation. It maybe the just different books or different styles, so either one's good. Okay, and then two vectors are equal if they have the same magnitude and direction. So the magnitude is showing the length, and then the direction is showing, yeah, where it's going, like a little arrow. All right, so to represent these, so we can represent them geometrically or algebraically. Usually algebraically is where we go with them because that's the easier way to start to deal with them. But there's two different ways to write them. So a vector in component form, usually again, back to our xy axis. So there's xy. Usually it's easiest to put our initial points on the origin, and then afterwards, whatever direction it's headed to is where we can put the terminal point. And so the way that we mark this down, so here's our vector v. In component form, we say we've got, you could do different letters. I'm going to do A1, comma, A2. Like that, where this is the horizontal component and that is the vertical component. So I used A1 and A2, but I mean, we could change the letters. So for instance, we could also say x comma y, really, if we prefer. Okay, so our horizontal distance would be right there. There's x or A1. Then here's our vertical distance, y or a2. Okay, so a1, a2. So the reason I do the a1 and a2 is because vectors, as you progress in math, maybe there's more than just the left, right, up, down. There might be more directions. So like 3D stuff, and often they'll start to do just little subscripts. Okay, but either way, so maybe the XY though is better for you. It doesn't matter. Okay, as long as we know the first one is a horizontal component and the second one is a vertical component. We also notice that I'm using sharp kind of they're not really parentheses. So I've got these sharp grouping method to use, so that way we know it's a vector, not just a point. So if you did parentheses, then we'd say, oh, that's just like a regular old point. Here we use these little arrow kind of symbols to again tell us that we've got a vector. All right, anyway, so let's express this vector in component form, and then we'll draw a vector with the initial point at the origin that is equal to this AB. Okay, so all I need to do is let's measure it in purple here. There's the horizontal component. There's the vertical component. Okay, and still just like xy coordinates, if I'm going left to right, that would be positive. Okay, so it looks like I've got 1, 2, 3, 4, 5, 6. it looks like I'm going to even label that, there's x. I'm going to say x is 6 just to the side. And then 1, 2, 3, our y is going downward. So I'm going to say it's -3. And then so our vector AB, which again, usually we'd probably abbreviate, just say V. Or some other letter, so we might use U or W. Okay, but it is 6 to the right, so 6, comma, and it's down 3, -3. Okay, so that is the vector in component form. And so what we want, now it's going to kind of overlap in this picture, but I'm going to draw what they said, the initial point at the origin. I just need to make sure I go 6 to the right, so 1, 2, 3, 4, 5, 6, and then down 3, 1, 2, 3 is about there, so it's a little off the grid. Okay, but then I can connect it, so there's my A, there's my B, and then I'm trying to connect it. There we go. There. So these are equal vectors because they're the same length and they're in the same direction. Okay, so these are parallel. Notice they're parallel as well. Okay, so that's how we can visually, again, geometrically is the drawing, algebraically is the numbers over here, and the symbols. All right, so let's see one other thing involving vectors for now. So it says let V be the vector from initial point P1 to terminal point P2. Let's write in component form. Okay, I mean, I can sketch these just like any time in math where we have points. Okay, so 1, 2, 3, 4, 5, and then up 3. There's point 1. And then 6 and 5, 1, 2, 3, 4, 5, 6, 3, 4, 5 is there. So there's our vector. Okay, and we could literally count like we did on the last problem. I can count the horizontal and I can count the vertical. Okay, but the other way to break this down, so I'm going to say here's my vector. This length, the horizontal length, is the difference, I'm going to keep this in purple, is the difference between our x coordinates. So I'm going to say it's the x2 coordinate minus the x1 coordinate. So there's x2, there's x1. And let's go ahead and label them now. There's y2 and y1. Our vertical component would be the difference between those y coordinates. Okay, so the second point minus the first point information. Okay, so again, we could just count it on this problem too. We could probably read it fine, but let's go ahead and plug those in and simplify. So we have 6 minus -5, comma, and then y2 is 5 minus 3. And then simplifying this, it looks like it is 11, comma, 2. Notice they're both positive, so that means it should go right and up. That is what's happening. Yep. Okay, so that's what our picture's doing. And again, we could have just counted. So from -5 to 6, 5 to get to the axis, then 6 more is 11. From 3 to 5, yeah, I would go up 2. Okay, and then just make sure it's in the right order. That horizontal component first, vertical component second. Okay, so that's how we can deal with these vectors for now, just representations of them. Okay, so let's put a pause. That's page 1, and we'll come back for another video on the next material. Okay, thanks for watching. See you then.